physics really builds on itself. My view of physics is it's a pyramid, but it's on its point, and chemistry is a pyramid that's on the base. In chemistry, you learn this, and it's a brick, and then you learn that, and it's a brick, and you learn this, and it's a brick, and they don't necessarily connect. And eventually, you have a nice foundation for a pyramid if you stick with it. Physics tries to get as much as possible out of as little as possible. And so if your foundation is a little shaky, the whole thing tends to fall over. Okay, so definitely early in the term, get those questions answered early and often, just like voting. Okay, so we've been talking about separation of variables as a way of solving the kinds of equations that come out of dynamics. They involve the acceleration, which is the second derivative of position with respect to time. And so we end up learning techniques for solving things when the acceleration isn't just a straight function of time. And as we've seen from fluid problems, it typically depends on the velocity. And so I'm going to work another example of that. And then I'm going to talk about winches. How many of you sail? 1, 2. Most of you are landlocked, apparently. So if you sail, you may have run across a very useful device called a winch, and we're going to discuss it, and it will amaze you about how effectively it can hold, provide a holding force for a rope, and we'll get to that in a little bit. And then I'm going to show you an example of practical winching from a little excursion I took 4 years ago in Africa with some engineering students. So first, let's do a problem. And I would like you to set it up on your own, and then we'll work it through. So I'll give you a couple of minutes. We have now quadratic drag on a sphere, and we'd like to find the particle's velocity as a function of time.